Okay, so let's see what we have in the problems. We have a number of interesting situations here. Let's see how we work on them. Okay, now here, the first one over here is 2p squared q cube upon 3xy, the whole raised to 0. It looks a little complicated, but think about it. It's nothing great. The whole thing has been raised to 0. It doesn't matter what's inside. As long as the number is raised to 0, any number raised to 0 is 1. So the answer is definitely going to be 1. The same thing, suppose it had been like this, 2p square, say L cube, the whole raised to 0 upon 3xy, then it's going to be 1 upon 3xy, because only this has been, just 2p square L cube has been raised to 0. This is xy raised to 1, 3 raised to 1, x raised to 1, y raised to 1. So this is 1 upon 3xy. But here the situation is the whole expression has been raised to 0. So there is no need to sit and calculate. It's understood that the correct option is 1. So the answer is 1. And yes, we didn't go wrong there. Now let's see what further interesting things we have. So here we have this concept here. We have x raised to 1 by p, which means the pth root of x is equal to y raised to 1 by q is equal to z raised to 1 by r, and xyz is equal to 1. What is the value of p plus q plus r? xyz is equal to 1. That is, when you multiply x, y and z, we get the answer as 1. So let us see how we can work on this. Now if you see, then the value of p plus q plus r is what? So we can equate this whole thing to say some number, say k. Say let this be k. So if x raised to 1 by p is equal to k, and y raised to 1 by q is equal to k, and z raised to 1 by r is equal to k. Now in that case, if that is the case, this means that k is the pth root of x. So if you take pth power on both sides, to do away with this, you take, just for one example, you take the pth power of this. This will become k raised to p. This we know it's x raised to 1 by p into p. So ultimately, this means x is equal to k raised to p. Much the same way, y would be equal to k raised to q, and z would be equal to k raised to r. Now it has been given that x, y, z is equal to 1. So that means this into this is 1. So instead of x, we can put k raised to p. Instead of y, we put k raised to q. And instead of z, we put k raised to r is 1. Now, this, again, we go back to the first law. Same base, different indices. So it's k raised to p plus q plus r is 1. Now, there is not much of confusion here. We can even go one step further for just to consolidate the rule, k raised to p plus q plus r. Now this 1 can be written as k raised to 0, because 1 can be written as any number raised to 0. So now we have the bases are equal, hence naturally the indices have to be equal. So we have p plus q plus r is 0. Hence among these, p plus q plus r should be 0. So whenever you have a case wherein we have one or two quantities equal to each other, we can equate them to k and then use the other relationship for substitution. We'll come across more such examples further so that you can really get a real good hang and understanding of how we can use this kind of concept of many terms being equal. You can equate them with k. So we have each of them is equal to k. So hence that means each of them. So if x raised to 1 by p is key, which means that if you take the pth power on both sides, say for example x raised to 1 by 3 is k. then you take cube on both sides. So x raised to 1 by 3 cube is x, and this becomes k cube. So much similarly you get this, and hence we have x is this, and since we know, now we substitute in this particular relationship, and hence we are getting this particular rule. So hence p plus q plus r is 0. So among these, this is the right answer. Let's check what we have. Yes, and we do have that. Much ahead, let's see what we have in store. Okay, so we have the next one. It's x plus y raised to 2 by 3, x minus y the whole raised to 3 by 2. The product of these divided by root x plus y into root x minus y the whole cube. Now how do we write this? So let's put this in a big bracket. So it's x plus y the whole raised to 2 by 3. Remember, this means that it is x plus y the whole square and the cube root of x plus y the whole square. Similarly, here you have x minus y the whole raised to 3 by 2. What does this actually mean? It's x minus y the whole cube, and since it is 1 by 2, you take the square root of x minus y. And what are these two? Here we have root x plus y, so which is the same. You don't normally write 2 here. It is taken for granted. Root means second root of x plus y. That is x plus y the whole raised to half into, now here we have two powers involved. It is root x minus y cube. This thing has been raised to 6, so this thing can be written as x plus y raised to 2 by 3. So let's upon x plus y raised to half. We can even split up, collect the terms with the same base together, because we're going to use the rule a raised to m upon a raised to n. Into, we are separating. Now these two are of the same base, so we write it as x minus y the whole raised to 3 by 2. Now coming to this one, this is actually x minus y the whole cube raised to 3 by 2. So it is x minus y the whole cube. Since it is square root of that, it's x minus y the whole raised to 3 by 2. So, and this whole thing has been raised to 6. So in this particular problem, you're using the rule a raised to m upon a raised to n is a raised to m minus n. A raised to m upon a raised to n is a raised to m minus n. Now if you look at this one, there is no need to root. Both these quantities are one and the same. X minus y the whole raised to 3 by 2, x minus y the whole raised to 3 by 2. Now these two directly get cancelled. In any case, just to make our simplification easier. So now we are left with only one pair. So we have x plus y the whole raised to 2 by 3 divided by x plus y the whole raised to half. So we're using the rule a raised to m, that is x plus y the whole raised to 2 by 3 upon a raised to n, which is a raised to m minus n. And this thing has been raised to, we should not forget that the 6 has been carried forward. So it's x plus y, and here you have the LCM 6. 6 by 3 is 2, 2 into 2, 4, 6 by 2 is 3, 3 into 1, 3, and this whole thing raised to 1 by 6. So now we have x plus y the whole raised to 1 by 6 and this thing raised to 6. So ultimately it has become a raised to m the whole raised to n. So we use, yes, the power of power rules. So we use x plus y the whole raised to 1 by 6 into 6, which is ultimately x plus y. So our answer is x plus y. So here we have effectively used the concept of rules, and you see that when you simplify this, this turns out to be the same. So it's directly getting cancelled. So there is no need to use any law of indices over here. So among these, this is our right option. And yes, we do have that as x plus y. So that was a little complex one. Let's see more examples. Okay, so here we have 2 raised to half into 4. Remember something like this we had in the earlier part of it, understanding the laws. We just need to extend that. 16 raised to 7 by 8, 32 raised to 9 by 10, the whole raised to 4, the whole raised to 3 by 25 is what? Now we need to go slow and careful over here. They've asked what is it? Is it a fraction, an integer, 1 or none of these? So now, as usual, since all these are powers of 2, convert everything to powers of 2. So this becomes 2 raised to half in any case. This would become 2 square raised to 3 by 4 into 8 is nothing but 2 cube, the whole raised to 5 by 6. Yes. 16 is 2 raised to 4 raised to 7 by 8, and 32 is 2 raised to 5, the whole raised to 9 by 10. This whole thing has been raised to 4, and this has been raised to 3 upon 25. So now this, if you see, is nothing but 2 raised to half into 2 raised to 2 into 3 by 4, which becomes 3 by 2, into 2 raised to 3 into 5 by 6, which is 5 by 2. This becomes 2 raised to 4 into 7 by 8, which is 7 by 2, into 2 raised to 5 into 9 by 10, which is 9 by 2, the whole raised to 4, and this whole thing raised to 3 upon 25. So ultimately this becomes 2 raised to half into 2 raised to 3 by 2 into 2 raised to 5 by 2 into 2 raised to 7 by 2 into 2 raised to 9 by 2. Common base, different indices, so we write it as 2 raised to half plus 3 by 2 plus 5 by 2 plus 7 by 2 plus 9 by 2, the whole raised to 4, the whole raised to 3 by 25. So you have 2 raised to half plus 3 by 2 plus 5 by 2 plus 7 by 2 plus 9 by 2 raised to 4, the whole raised to 3 by 25. This will turn out to be 2 raised to, if you add up all these, it turns out to be 25 by 2. The whole raised to 4, so into 4, the whole raised to 3 by 25, so into 3 by 25. So in other words, it's power of power of power of power. So you can multiply, so it's your further applying it to 4. So it's a raised to L into raised to m, the whole raised to n. So it's a raised to L m n. So you're multiplying all these. So hence we have 2 and you have 2 raised to 6. 2 raised to 6, which turns out to be 64, or even if you don't calculate 2 raised to 6 among these, it's not a fraction, it's definitely an integer. So this is how we calculate. Basically, we are using the various laws that we have. But very important thing, always convert them to prime factors. So 4, 8, 16, 32, all these are powers of 2. So we write them as powers of 2. Let's see what we have. Yes, it is an integer. Right. Now, let's check the next situation here. Okay. So here we have minus half, minus 1, and all that. So ultimately, this is going to be 1 minus 1 minus 1 minus x square, the whole raised to minus 1. And this has been raised to minus 1, and this whole thing has been raised to minus half. So now we don't disturb the outer bracket. We go to the innermost bracket, that is this. So it's 1, and this whole thing continues to be minus half. Or if you want, you can start with this, but you might lose the continuity. So we keep it 1. And now this is smallest bracket, so we have 1 minus x squared, the whole raised to minus 1. So it's x raised to minus a, which is going to be 1 upon x raised to a. So this whole thing. So this is gone, but this has been raised to minus 1. Right. So now let's make this simpler. So 1 minus you take the LCM, it turns out to be 1 minus x square minus 1 the whole raised to 1 minus x square, and this has been raised to minus 1 and this has been raised to minus half. So this gets cancelled, and let's see what we have here. We have 1 minus of minus x square the whole raised to 1 minus x square the whole raised to minus 1. This whole thing is raised to minus half. Now here again we go to the next small bracket, so it's raised to minus 1. So again we use the rule 1 minus a raised to minus m is 1 upon a raised to minus a. So it's 1 minus the reciprocal of this. So which is 1 minus x square upon minus x square, and this has been raised to minus half. So now here this minus and minus of minus can be made positive. So we can write this as plus. Again take the LCM. So if you take the LCM, it's x square, and here it is x square plus 1 minus x square the whole raised to minus half. Here this gets cancelled, and ultimately it's 1 upon x square the whole raised to minus half. Now this can be written how? We can write this as, since it is 1 upon a raised to minus m, so we can reciprocate it and write this as x square raised to half. Because it is 1 upon some number raised to a negative, so it will be the same as the reciprocal of this number raised to a positive power of this. So this becomes x square into half. Using the rule a raised to m, the whole raised to m is a raised to m into m. So this becomes x raised to 1, which is x. So basically what we are doing, we start with the smallest bracket. We write it as 1 upon 1 minus x square, take the LCM and you get this. Then next move to the next bracket, further reciprocate it. So it becomes 1 minus x square upon x square, the whole raised to 1. So here you might a little bit of think that another alternative that you could possibly do is, since it is 1 upon x square, we could even write it alternatively as x raised to minus 2 the whole raised to minus half. So you converted 1 upon a raised to m as a raised to minus m. So even this could be done, minus 2 into minus half. So even this gives you x raised to 1, which is the same as x. So you either do it this way or you do it this way. Ultimately, you're getting it as x. So I'm sure this is what the answer would say to yes. This is the option that we have over here. Right. So that was, these two ones were a little worth working out a little more in terms of steps. Let's see what we have in store further. Okay, so here we have something quite similar to it. So we have x raised to n, the whole raised to n minus 1 divided by n, and this whole has been raised to 1 upon n plus 1, and it's told what among these is the option. So we're going to start with the smallest bracket as usual. So using power of power rule, so it's going to be x raised to n into n minus 1 upon n, and this one has been raised to 1 upon n plus 1. So we have here this, so this n and n get cancelled, so ultimately it is x raised to n minus 1 into 1 upon n plus 1, which will be x raised to n minus 1 upon n plus 1. So ultimately it's x raised to n minus 1. You can even verify it orally, just multiply all these, the n and n get cancelled, so you're left with only n minus 1 upon n plus 1. So this should be the right option. But among these, sadly, we don't have these options, so the option is going to be none of these, because it's going to be x raised to n minus 1 upon n plus 1. And yes, it's none among these. Right. So from here, we move over to the next. So we have this particular formula here, that we are using the rule that a cube minus b cube is this. Mind you, this is not the same. A cube minus b cube is not the same as a minus b the whole cube. Okay, we need to be very careful over here. So it's a cube minus b cube is a minus b into a square plus ab plus b square. You're using this particular rule to solve this. Now, how can we do this? Now, if you see, the first step is, let's take the first expression. The first expression is x raised to L upon x raised to m. You need have to quiz upon this. We use the rule, same base, different indices, division. So we write it as a difference of the indices. This has been raised to L square plus Ln plus m square. Then next we have in store is x raised to m upon x raised to n, which is x raised to m minus n the whole raised to m square. Here it is L square, I'm sorry, m square plus mn plus n square. And finally we have this particular term, the last term, again it's x raised to n minus l the whole raised to l square plus ln plus n square. Now we use the rule power of power rule. So it's a product of these. So x raised to L minus m into L square plus Lm plus m square into x raised to m minus n into m square plus mn plus n square into x raised to n minus l into L square plus Ln plus n square. So here we apply this a minus b into a square plus ab plus b square. So same way you have L minus m into L square. So here we have our a, this is drawing parallels with this, this is our b. So this ultimately becomes x raised to L cube minus m cube into x raised to, similarly it's a minus b, a square plus ab plus b square. So it's m cube minus n cube into x raised to n cube minus l cube. So ultimately we have x raised to, so now we have same base, different indices. So what do? Yes, if you remember, we are writing the common base, add up all the indices. Plus m cube minus n cube plus n cube minus l cube. So this gives you, of course, all the terms are getting cancelled and you get x raised to 0. And yes, any number raised to 0 is going to be 1. So our option is going to be, or rather our solution to this particular expression is 1. So among these, yes, this is our answer 1. Yes, let's check. Yes, we do have that. So now further we can, since now that we have solved a couple of complex problems, we need to take this to the next level. So let's see what we have here. Okay, here we have gone into, I told you in the last example that a cube minus b cube and a minus b cube are not one and the same. So you have, using this particular rule, we have this. Tick the correct of these. When you have x equal to p raised to 1 by 3 minus p raised to minus 1 by 3. Which among these is this? Now if you observe, keep that as, say, equation number 1. All these expressions have x cube. So the best thing to do is we could cube both the, and this plus, using this particular hint that you need to apply this law, we can cube both the sides. So it is x cube is equal to p raised to 1 by 3 minus p raised to minus 1 by 3 the whole cube. So this remains as it is. So here we're going to use this rule, a minus b the whole cube. A minus b the whole cube is a cube, that is p raised to 1 by 3 the whole cube, minus b cube, that is minus p raised to minus 1 by 3 the whole cube, minus 3ab, so it's minus 3p raised to 1 by 3 into p raised to minus 1 by 3ab, sorry, into p raised to 1 by 3 minus p raised to minus 1 by 3. So it's a cube minus b cube minus 3ab into a minus b. Now this, if you use the power of power rules, we can write this as p raised to 1 by 3 into 3 minus p raised to minus 1 by 3 into 3. This would be minus 3 raised to 3 into p raised to 1 by 3 minus 1 by 3, which is going to be, and this we can resubstitute for our ease. We can resubstitute this as x because we know x is this. So we write this as x. And this whole thing is of course x cube. So we have x cube is equal to p raised to 1 p minus p raised to minus 1 minus 3 p raised to 0 into x. Now this is going to be x cube is equal to p minus p raised to minus 1. So you're using the rule a raised to minus 1. This minus is going to be here. You're going to write this as 1 by p minus 3 p raised to 0 is 1. So 3 into 1 into x. So we have 3x because p raised to 0 is 1. Now we need to simplify this further. So we can possibly take this to this side because among these options, what do we have? So we can transpose this to this side. So we have x cubed plus 3x is p minus 1 by p. So thus we have x cubed plus 3x is equal to p minus 1 by p. So among these, it's definitely not this. Yes, it is this. This is definitely not this. So x cubed plus 3x is equal to p minus 1 by p is our man. So hence, this is the option. So basically, remember one thing here, this particular rule has been applied. So you're cubing it. So it's a cube minus b cube minus 3ab into a minus b. And we can substitute this as x. So all these places, you're applying the various rules and laws of indices. Right? So let's check the option, of course. Yes, that is the option here. So slowly we are upgrading our difficulty level of the problem. Now, let's see what we have further.